The question is, are we hitting the roadblock? And before that, maybe just to say a couple of words about the company. We are the automation low-code platform, and there is some connection, obviously, to the serverless. Now, before that, maybe just to introduce the low-code platform and what we mean by that. The low-code development is actually a promise that developers only need to code with very fast pace, with the minimal setup effort and very quick deployment. It reduces the complexity of the application development, and obviously there must be some building blocks in this platform that, like a snippet of code, which allows us to reuse these Lego blocks. Now, I could not resist to put the next slide because I was not the first guy on this conference today. And I knew that some other people will have Lego analogy. Obviously, Mr. Shen Brisas from Lego Group was the obvious choice, but he actually didn't see that coming from Frank, who was talking about API, and indeed, in the context of API economy, thinking and making the analogy to the Lego blocks. In context of the low code, and what we mean by low code, we mean snippets of code, we obviously also think about this as Lego blocks, but in context of the service, we often think about lambdas or cloud functions as these building blocks on top of which we're going to build applications. And obviously, what you see here on the screen, it's one very small, innocent lambda call, which does fairly anything. Now, first of all, where the service really makes sense, or rather to say where it really works well. This is in the batch processing, in the machine learning pipelines. Basically, you get maybe an image, you do the image processing, you end up in creating alerts. For instance, my daughter works on the cancer research projects, and they work with the service a lot for the deep learning analysis of the CT scans. It really works well. Now, the next place where people often use the serverless is in web applications. There, obviously, what people do, they use some sort of a CRUD elements facilitated by the Lambda functions, and eventually this operation ends up in something like a DynamoDB. Now, what we can do with this is obviously we can do the infinite scale because we can just simply add new functions, providing we solve the problem of the cold start. And for instance, if you have a web shop, you can survive if you like a Black Friday. Now, if you go one step further and you would like to really build some more serious applications, this is where the stuff becomes interesting. And this talk, it's really about that part. Now, what you see on the screen are actually two different applications built on top of serverless. On one hand, you see the banking app written with 1,500 different microservices. On the right-hand side, I feel like a PCB engineer looking at analog and digital electronics. This is how things become very, very complicated once you start really deploying serverless in production. Now, what is actually industry saying? What's actually the problem? There are two different impediments that are hampering serverless adoption. The first one is architecture complexity. And we'll see later on, and also in this conference, a lot of talks about traceability, observability, debugging, tools, and so forth. And the other, if you look a little bit more closely into the surveys, you'll see it's about fear. Fear of losing control, fear of vendor locking, fear of weak security, unpredictable cost, and so forth. Now, let's see what we are talking and what we are saying, service adopters, AWS heroes, or any other engineer who is actually using the service in day-to-day work. And these are the people who I really admire a lot, and I'm following them and following their tweets. And they're also sometimes themselves asking, are we missing something? Are we missing a portal? Because there are a lot of scattered services. Are we requiring new skills to actually use in this paradigm? Do we have a problem with infrastructure? I said the promise is that we do not have to manage the infrastructure. Is this really like that? Are we actually adding complexity rather than reducing that one? Do we need better debugging and troubleshooting? Do we still need a multi-cloud paradigm? And do we understand really something like young policies? Is it all that simple as we think about it? Now, if you look at the survey, and I'm going back to what O'Reilly has published some time back, we still see that majority of companies are still not introducing the service. And if you're looking for a why question, you'll actually see many problems in there, like educating current staff, vendor locking, integration, testing, observability, debugging. and other things that I have mentioned earlier on. So there is really a problem. And then basically boils down to one question. When you start a new application or a new company, should I use serverless or not? Like I mentioned early on, there are places which it makes sense. You have a small snippets of code, you have infinite scale, you can actually do separation of responsibilities, meaning that you can really segment your company, so to speak, and knowledge into subject matter experts, IT folks, DevOps, machine learning guys, solution architects, and so forth. But is it really so easy to develop and deploy and to support in production? Or I can actually take something like, good old lump stack, being Django, Rails, Express, depends on language you like, and then do easy implementation, deployment, and use it from your laptop, put it on Yastek, DigitalOcean, and so forth. That's really the question. So this talk, it's about the guilty one. Now, if you look at serverless, it's actually not so new in the sense that we talked for a long time about serverless compute, about cloud functions, but we also remember things in discussions about functional computing or object oriented, which is better or not. And if you look at the small snippet of code, or rather what we see here as a Lambda calculus, we are simply chaining functions. It is very simple. So why didn't people struggle about it? If you look at the right-hand side, we still have to educate stuff. Why is that? Because we just have functions. Why we are still talking about testing, observability, and so forth? Are we really fixing the symptoms or the cause of the problem? Now, I will step back a little bit, and I will point out to one great paper. There are many great papers, and obviously there are some from Berkeley University, which talk about serverless. And I would encourage people to read them. And obviously, they talk about things that we know here in the conference about cloud functions, big data queries, object storage, and so forth, as you are moving the, let's say, abstraction paradigm from Yastek more and more. So what's actually the problem? Well, it's a coordination problem, because if you have a task A which requires the output of the previous task, someone needs to tell him, oh, there is something available for you. Moreover, if you have many of these things, you have to orchestrate multiple functions, and you need to coordinate all of these things. And finally, you have to really deal with the data dependencies. And you will see through this paper, they're really promoting the idea of having some sort of a computational graph which simplifies these deployments. And obviously, we know now there are many of these, including AWS step functions, and they're mentioning that in the paper. That's one problem. The second problem is that we have not solved yet. It's about entities, because we still need to code them somewhere and reside that in some place, like a DynamoDB, or maybe in context of Internet of Things, digital twins. Then we talk about entities, or maybe GraphQL. Maybe we need to have some graph database, or maybe ontology, semantics, GraphQL, sorry, SparkQL kind of databases, or simply put them in the databases. We still need these things as well, which boils down to one thing. Regardless whether we use one database or the other, or we use the cloud functions, Amazon or Azure, we still need an orchestrator. So what we have, I already mentioned step functions. This is nothing but a finite state machine. What we do here, we are basically, in a way, isolating that function, wrapping around with some sort of a states, and basically we can track what's happening with the execution. And that's one way to solve the problem. Now, what Azure does, they have something called logic apps. They're kind of a flow engine. And for people who are older, like my generation, they remember Yahoo pipes, and there were many similar technologies that are actually trying to solve that sort of a problem using the flow engines. There are others, of course, and now I will just mention, to stay at a big three, Google, which has come up with some strange thing, YAML-based flow engine, YAML-based orchestrator. Basically, we can read out code how they do that. Basically, have a switch and conditional execution within the YAML file itself. People can do that as well. Now, to illustrate the problem, I will basically talk about OT-IT convergence, because this is where we as a company are primarily busy with. It's actually Internet of Things together with linking with machine learning and other backend systems. Now, often when people talk about OT-IT convergency and challenges, they really mean by that the data aggregation and these sort of challenges. Here I will talk about automation as a problem. So what I mean by that, let's take a finite state as an orchestrator, which can really work very well in many different cases. I often find the knowledge of finite state machines to what Taleb one called like a stock market. It's a big movie theater with a small exit door. In a way, finite state machine is an opposite of that. It's a small front door to a big theater. And you cannot really process more than one event at a time. There is only one guy who can enter inside. But obviously, there are other places where this really makes sense, in the workflows, ticket handling, and so forth, where you have a highly correlated event or alarm, and then you have to manage that. But you cannot use that to manage data streams. It's impossible. Now, other option you have then is to use the flow engines, because they can ingest data streams. But coming back to the control and decisions, which I talked about signaling, it's really very hard to understand what's going on. You actually pass the output from one function to the other one, but it's actually very hard to understand what's going on here. We can maybe read these labels, but essentially the problem of interpretability and then against observability, it's actually a big deal. And I will illustrate that in a couple of use cases, an example from our customers. Where it does work, we have a batch processing. Basically, we have on the left side a device which sends data. You can also actuate back. And then you have the shadow of that representation somewhere in the cloud, what we call digital twin. You push data into the database store and you do reports analytics. But how you then use information from other sources like APIs or a digital twin? You cannot do it. You can only inject it once in offline way, but you cannot use it in real time as a stream. In order to achieve that, what people can do is to push data in the object store and then invoke the Lambda's own object creation, and then can start grabbing information from other places. And then as well, launch the machine learning models and so forth and so forth. Or other thing you can do is to basically plug a kind of a stream like analytics engine, which can do the query on the stream itself. That is to say, I'm going to do the query and find any device which has a temperature higher than 21 degrees. I can do that. But what I cannot do is to find the configuration of that device at that moment in time. What if I have to set a different temperature thresholds for different devices? I cannot do that because I don't have this data at the moment that the stream arrived. I cannot use the API command. I cannot use any other system, only the one which is in the stream. In order to solve that, I would need to push it back into the Lambdas and then invoke yet another workflows to manage that, because then only then I can actually go back and find some additional configurations. People do that as well. The other option I have is to take some sort of an orchestrator which can deal with the streams, like a Lambda itself. And then I have a fan out of functions. If I have a lot of events, I will have a fan out, and obviously we can infinitely scale, but we still have to ask ourselves what's going on here. And then when, again, we have a threshold crossing, then invoke yet another workloads. That's the real problem. So basically, when we talk about OT-IT convergence dilemma in context of automation, we really have only a few choices with existing technologies. Either put something on S3 bucket, then invoke the Lambda function, and then invoke the step functions. And it's great for batch processing, and that's about it. Or a highly correlated events which need to be managed by some sort of finite state machine. Or use the stream analytics, and then followed by the orchestrator. In that respect, you have actually two roles in two different places. And finally, you can just tap into some sort of lambdas, but then how you manage that complexity, fan out a lot of things which are happening at the same time. Now, as I mentioned earlier on, Waylay, it's an automation platform, and early in our existence, we realized there is probably a better way to solve that problem. But instead of thinking about automation as the afterthought, let's try to think about automation as a STAR topology, meaning that automation technology needs at any moment in time a constant connection to streams, to time series data when it's stored. You can run then prediction models. You can also then access information from the meta models like a digital twins or relational database, IT systems, and so forth. Which brings me to another topic. You need another kind of orchestrator. I call it a STAR Orchestrator because it really needs to actually capture all these complexities and manage to deal with the stream data at the same time, being able to be as interpretable as a finite state machine. And that's actually what we have built. Now, in order to illustrate that, I will basically step now from the presentation as I'm still sharing my screen, and maybe just show that, because I see now I have plenty of time still. So what I'm going to do now is that I will be pushing data for one particular device. In this case, I will have a patient Steve, for who I'm going to push data through different medical devices. I'm going to send him a temperature, heart rate, respiratory rate, and all other things into our system. So basically, I'm now on IoT side sending data to our low-code platform. Now, once I'm in the low-code platform, I will be able to actually visualize this stream data in our environment. But what I want to do now is to orchestrate these streams. So what I'm going to do now, I will just show here how we actually do that in reality. I will take, let's say, one template, and what I'm going to showcase here is how we can, in our system, ingest these streams and interpret this data as if it was just finite state machine. So what I'm doing here now is that basically, what you can actually see, you can read it out together, is that I'm ingesting the streams, I'm invoking the cloud functions, I'm treating them as a finite state machine. At the same time, I'm able to basically wire this logic together, meaning that if I have something called a SIRS criteria and there is infection, let's maybe make sure that Steve suffers a little bit. And because of that,
shock for the patient, Steve. Alert.
I just got a call that poor Steve got a sepsis shock. Why is that? Because one Lambda function here got invoked because this patient was getting in trouble. So this is how easy it is with our automation platform, if you like to merge the two worlds of the streams together with easiness of understanding and interpretation from the finite state machines. Now, in order to stay at this level, since I'm now already in the platform, maybe just to show you some other things as we are here, as I was pushing the data, I was also at the same time storing this data. And that's what we can actually see here. I've been for the past, if you like, minute or so, pushing to data in our environment. And if I was now a machine learning expert, I will basically use my Python notebook, which is actually my local host here. And I will be playing the game of being a data expert who wants to actually do the same analysis, but instead of using the, if you like, a finite state machine and the rules, I will actually try to run the machine learning models, which should do more or less the same thing. I'm creating the isolation forest model for unsupervised anomaly detection. In this particular case, I will monitor patient Steve. And if I then find the problem, I will actually create machine learning models which satisfies these conditions. Once I've done that, the last thing I want to do is, or rather that I would like to do, is to basically upload this model in our environment. And again, by the same token, I can just now take this model. So this is this little small cloud function here, which is my model which I have built. And again, if I would like to test my patient Steve, let's do that every 5 seconds now. Rather than executing cloud functions on the streams, I will basically now fetch the data from the time series database, feed that to my machine learning model, and if then the outlier is detected, in that particular case, that would be anomaly detection being a sepsis shock, I would actually fire the alarm. And again, I would get a call. And this little snippet of code, that ladder block that I was talking about before, would in this particular case be this. So this is how easy it is to implement this pretty complicated use cases through our system. So let me go back to presentation and let's just skip this video and basically say a couple of things that it's about Waylay IO platform. So our mission is to bring that Apple experience to developers community. We really believe that even though engineers often take pride in doing very complicated hard things, and they take a pride in understanding and owning that knowledge, we still would like to think of experience where basically you can take that energy and if you like, that imagination you have and to deal with the right things, which is actually implementing your use case, rather than being really bugged into the deployments, observability, and so forth. So what we actually have, we have a local portal that simplifies development and deployment. We really have an easy way to integrate APIs from any other third party. Basically, these are the small snippets of code which at the runtime you can extend with any other information and the system that you have under your disposal. We also can implement machine learning models. You actually saw me now, literally within a couple of seconds, rather a minute, implementing new machine learning model. Obviously, you need to know your subject, so to speak. And then once you're happy with your machine models, you can actually deploy it in an environment and use it in the same way as you were using that, using just stitching the cloud functions. Debugging and observability becomes a much easier problem to manage because, like you've seen me doing, I can actually monitor every automation use case and at any moment in time ask myself why these things are happening. You have all tools in one place, and basically from development to production, there is really nothing that you need to do. You can simply apply these use cases to familiar devices. I don't have time to show it now, but you can imagine having a different machines with a different kind of problem, so to speak. You can create these sort of templates which are applicable to only some subset of your complete managed system. So maybe just I would like to mention something that, as I mentioned earlier on, we are a cloud agnostic platform, which means that we are really trying. Sometimes this might sound as a famous last words. You know, not that many people have managed to create something which is truly multi-cloud agnostic. Reason being, there is a lot of cloud providers are really providing off-the-shelf ready-made things that you really don't have to manage. We manage it for you, but we are really also bringing, or if you like, giving back to community. We are really paying for the platforms and open source components that you're using under the hood, so to speak. And we are a great advocate of OpenFaaS. As well, we are using some other things which are obviously familiar, you guys are familiar with, like Kafka, Redis, Cassandra, Mongo, Elastic, and so forth. And not to forget to mention Kubernetes, which is the container technology, which we use for our infra deployments. So this is basically, you can actually look at back later on in documentation and to understand how we actually created such a platform and the automation stack. We have nothing to hide. In contrary, we really like to engage with people and developers and architects and to basically explain how we actually have created such automation framework. Now, the one thing that I often get a question, how fast this can be? What I want to say, I mentioned early on a fan out of functions. That is to say, if the streams are coming very fast, let's say in a couple of milliseconds, and if you have to launch a Lambda function, it's not just how function fast can be. There is some sort of RPC call. There is some sort of penalty that you need to pay for, even for round trip delay. What if you can create a cloud function which is a native to the orchestration container? What if we can think of the orchestration container as something which also hosts the Lambda functions? And that's actually what we have built. We have built some sort of a plugin interface which allows us natively to build the functions within Orchestrator and as well use this together with all other API functions which are external to the Orchestrator itself. What does it mean? Is that we can ingest the data and streams very fast and execute these internal calls, at the same time injecting the configuration of these objects. I mentioned earlier on something about digital twins. If you have a configuration that your threshold setting has to be 20 rather than 21, you need still to go and fetch that information. What we do instead, we recognize what kind of assets you're dealing with and rejecting that in the stateful automation context, such that we do not have the penalty of the round trip delay to bring this information back to the automation. Finally, if you really still would like to call alarms, or like in my case, I was getting the call, you can still actually do the fan out. Fan out, then it's not a problem. First of all, because not all things need to be managed by a call. Not all streams need to get into the alarms. Some of these, yes. And then you can still do the infinite scale because you have a fan out. And in order to actually show that, here it's example from our Grafana where we monitor the round trip delays and execution time of all cloud functions. And I would just like to point out here to the native functions, which are basically 90 percentile executing less than 0.2 nanoseconds. So you don't really have to pay this external penalty, which is obviously what stream engines are doing. They're actually doing in-memory stream processing. Now, the other example that I would like to showcase here It's something we do together with Salesforce. This is an application that is available on the App Exchange, which is a digital twin. So let me just show you how we do exactly, well, technically wise, exactly the same thing. We have a data ingestion framework which enables us to tap into all other third-party IoT platforms, being Azure, being Amazon, MQTT, brokers, or whatever. And they be normalized as a stream within our environment. Then we invoke the cloud functions that are in this particular case native, meaning they're executing pretty fast. And then eventually we have a fan out back to the Salesforce, meaning that what you see on the left-hand side, we have an application which is built on top of our REST interface. All these rules, which are in context of Salesforce, something like the maintenance needs to happen on this machine. There is a normal detection algorithm running. You need to fetch or change some materials. And then eventually you end up with the application which is completely native within the App Exchange, while the heavy lifting, if you like, serverless heavy lifting, is happening on the Waylay side. The other example that I would like to mention is, if you remember, we talked about the entities and relations. Now, obviously, then you might be cornered in anyways needing somehow to express these relations one or the other way through the databases. And then eventually you may think of a problem. Is this my problem a graph problem? Is this my problem a reference problem, a linking problem, grouping problem, and so forth? Because you really need to code these references and relations. But let's think about it in a different way. Now, what I'm going to show here, it's something we've done for the ENGIE, which is a big electricity distributor in Europe. And they have a smart cabin project. And they're retrofitting, or rather putting some sensors, Sigfox sensors inside their cabinets, and they're monitoring the high voltage, low voltage, and medium voltage. And each of these sensors have a different roles. And out of these objects, they would like to create different rules. Some of them can be like, if this and that it's wrong, then you need to fire alarm. Or if I see the door open and nobody was supposed to be there, maybe you have to do some other rules, notification rules. So instead of then creating a database where each of these relations and use cases are coded into the entities, why not just express these relations at a rule level? And then you can actually recycle the same objects, and the relations become part of the use case template, a rule template. Then it's much easier to implement and add additional use cases rather than always going back to the database and figure out whether your UML diagram or a database schema adheres to the use case you would like to create. Finally, and this is where I was actually showing before the stuff about the machine learning models. This is also another example where instead of forcing yourself to be in some sort of the offline analytics mode, where you would first need to batch data, push it to the database, and then do machine learning models, why not do that at the moment that the data is arriving? But again, you still need the same sort of the framework that it can as well at the same time ingest the streams or run machine learners in exactly the same way. And this is what you actually see here. We are getting the data from the storage systems in the same way as if it was a stream. We execute that query, we feed it to the bring your own model. Then we can throw the snippets of code, which are basically doing the post-processing of the model. Why is that? Because here we're actually throwing the arrays of ones and minus ones. We can filter out and see what we believe it's an outlier, and then create alarm, create something in Salesforce, and so forth. The same is then true for the predictions. Sometimes we need to retrain models, sometimes not. I often see the companies which are saying we can do the automatic retrain of the models. What does it mean? If it's a anomaly detection, you cannot retrain, because otherwise you do not know whether it's an anomaly or not. It is really use case specific what you need to do as the outcome of the prediction model itself. In this particular case, we call it anomaly. Therefore, someone has to check whether the model is correct or indeed there is a problem in the machine itself. And I would use now this opportunity and to announce something. We've been around for about 7 years. And my first talk back in Berlin in 2019 was on a similar subject. And I still remember one engineer coming back to me after the talk and saying, can we try these things? And I was just saying, sorry, you cannot, because we are an enterprise company. Maybe you should talk to our boss or your boss rather, talk to our salespeople, and then we can get on a call and try it out. And we are a very successful enterprise company. Having said that, it was always for me a pretty sad story that I had to actually wave here with hands and showing the slides, and then I would just say, well, sorry guys, you cannot try it. Today, we are actually officially launching the product, which is not only in the enterprise, it's also developers friendly product which everybody can start using. We will start with free vouchers of $200. Please go on our website. We'll be more than happy to hear your feedback. Any feedback is a good feedback. And we are here to stay. There'll be plenty of fun for everybody. And with that, I would conclude my talk.